Hey, this is Dr. B, and we have a Science in the News activity for you. I'll be talking about the Ingenuity helicopter, which is a pretty exciting device which is launching tomorrow, July 30th, 2020. And in several months, it will then arrive on Mars. And on board will be not only this little helicopter, but it's strapped to the bottom of this Perseverance vehicle. And it's going to explore a particular crater that seems to have a spot where water ran in, water ran out. There's what they call a delta where the water runs in and moves sand around. And I think they chose it because it's a very has great potential for having ancient life that it once existed on it. So they've got another Mars vehicle, and let's talk about this Ingenuity helicopter. I'm going to show you the 1 minute video that has no words in it, made by NASA. I'll have you watch the CNET video, which is about 5 minutes long, which gives you some more useful data, and it's presented in a very user-friendly way. I think you should click on NASA's briefing to take a look at their overview. It's very professionally done, and it doesn't take long to go through their main points. And after that, we'll have a list of questions. So let's begin by watching the helicopter video by NASA. So that is the Mars Ingenuity helicopter. I'll have you watch this on your own. I'll provide a link for it. This is a 5 minute video by CNET. It goes into a little more detail. I mean, if you look at this thing, you'll notice that the rotors are particularly large. You may learn that they move at a particularly fast rate. There's two of them stacked on top of each other. There's a solar panel up here. This whole thing looks extremely lightweight. What powers it, right? How does this thing operate? And so take a look at NASA's briefing to learn many of the answers to questions such as these. And speaking of questions, here's some for you to answer. Number one, when does it launch? Or when did it launch? When does it arrive on Mars? And how far away is Mars? Now show the math to find out how fast it travels to get there. Be careful when you answer this question because due to the fact that we are moving around the sun and Mars is moving around the same sun, you can't just travel in a straight line to get there. So you might want to find realistic distance data and go ahead and do the math to find out how fast it is traveling or has traveled. Why is it hard to fly on Mars? You should see some basic information that shows the primary issue with flying on Mars, and it's really interesting how they had to deal with that in simulations here. You may also find some information on why it's maybe in at least some lesser respects a little bit easier to fly on Mars. I say all this hypothetically because you might be aware that no vehicle has ever flown on another planet, at least by humans that we're aware of, right? 6, how long are the daily flights? And a couple of math questions. I'm wondering how much energy that helicopter can soak up from the sun each day. Let's make the following realistic assumptions. And if you want, you can watch the Wired magazine or listen to read the Wired magazine article about this. Let us assume that the sun can provide 300 watts of useful energy per square meter each day. In terms of the size of that solar panel, it's only 154 square centimeters, not square meters. And let's assume 25% for efficiency for the solar panel. That seems realistic. That number there was obtained by thinking about what the total energy is, but then accounting for the fact that the sun's not above you all the time, right? And let's use the conversion of 1 watt equals 86,400 joules. From this, you should be able to fairly quickly come up with a joules per day in terms of how much you might expect how much energy you have to work with each day. Now, what the NASA engineers would like to do at that point would be to come up with the longest, most useful flight based on that. Don't forget, if you're solar based, that means you can keep doing this until the thing breaks down. Having said that, anybody who's owned their own drone knows that these things can break down. Another interesting point I think I might as well make is that it's nice to have a joystick here on Earth to control your drone. There was once a teacher at the school that I teach at that liked to take his drone and fly it into other teachers' classrooms while they were teaching. Some of them thought it was hilarious, others not so much. Okay, another math question. Let's compare that energy that you just got to that of that iPhone 11 that you currently have in your pocket. Let us assume that iPhone is a 4,000 milliamp base system. That's the size of your battery. Milliamp hour, they usually just write mAh. And it's a 3.8 volt battery. And to get your joules, just multiply the milliamperes times 3.6 times the voltage, compare it to that, and it might give you an idea of, you might say, oh, well, wow, the battery on that Ingenuity helicopter is worth 100 iPhone batteries, or maybe it's not even half an iPhone battery. So take a look at it and see how much energy they have to work with. And finally, what fascinates you most about the Ingenuity helicopter? Pick any topic you want. You only have to write 1 paragraph minimum, but I hope you'll write more because there's no maximum. Okay, I look forward to reading your answers about the Ingenuity helicopter that is launching tomorrow.